All right, let's just jump right in with a question that sounds like it's straight out of science fiction, but it might just be science fact. What if your mind, the very way you think, the way you combine ideas, actually operates on the bizarre rules of quantum mechanics? Today, we're going to explore a truly mind-bending theory that uses the weirdest parts of physics to explain the everyday magic of how we think.
And it all kicks off with this really simple, almost silly-sounding puzzle. Think about the concept of a pet fish. What's a really good example? A lot of us would probably say a guppy. But here's where it gets strange. On its own, is a guppy a good example of a pet? Not really. What about a fish? Well, it's fine, but it's probably not the first one that pops into your head. So how on earth does combining a kind of mediocre pet and a so-so fish suddenly create a perfect pet fish? This, my friends, is known as the pet fish problem.
And look, this isn't just a hunch. Experiments have actually confirmed this paradox. When people are asked to rate how typical a guppy is for different categories, it gets a low score for pet and just a medium score for fish. But for the combination pet-fish, that score shoots way up. The simple math just doesn't add up. It makes no logical sense. And honestly, this is a massive headache for the classic theories of how our minds form concepts. Whether you think we use prototypes or rules or specific examples, none of them can explain how two concepts mash together to create something totally new and unexpected. To solve this mystery, we're going to need a completely different kind of clue. So our first major clue comes from a really simple but incredibly powerful idea. Context is everything. The meaning of a word or a concept isn't locked in stone. It's fluid, and it can shift dramatically depending on the situation you find it in. Let's see this in action. Imagine I give you the concept pet, but I put it in a very specific context. Let's say, the pet is chewing a bone. What kind of pet immediately pops into your head?
And yeah, as you'd totally expect, dog becomes the absolute best example of a pet in this context. A parrot? Yeah, not so much. Its typicality rating just completely tanks.
But watch what happens when we just switch the context. We'll keep the concept pet, but now the situation is, the pet is being taught to talk. And boom, just like that, the ratings completely flip on their head. Parrot is now the star of the show. It's a perfect fit for that context. A dog? Now that seems like a pretty weird choice. So you see, the context didn't just nudge the meaning. It completely rewired it. This leads us to a really powerful new way of thinking about this. A concept isn't some static entry in a mental dictionary. No, it's more like a dynamic thing that can exist in different states. A context, like chewing a bone, basically forces the concept into a specific state, making some features stand out while others just fade into the background. Okay, so concepts are flexible, they change with context, got it. But how does that help us solve the guppy problem? Well, this is where our investigation takes a very surprising turn, because we're about to borrow a toolkit from the most famously counterintuitive field in all of science, quantum mechanics. Here's the big, wild idea. What if a concept, before you put it into a context, isn't actually one single thing? What if it behaves like a quantum particle, just existing in a blurry haze of multiple possibilities all at the same time? We can actually break this down with a simple three-step analogy. First, you have superposition. A concept like pet isn't just dog or cat or fish, it's a sort of cloud of all its potential meanings at once. Second, think of context as a measurement. When we introduce a context like chewing a bone, it's like a scientist making a measurement. It's asking a specific question. And third, you have collapse. The instant that question is asked, that cloud of possibilities collapses into one single definite state. The concept pet just snaps into the state that's most compatible with chewing a bone, which, of course, is dog. Now, this idea of superposition and collapse is pretty cool, but it's another quantum trick that gives us the final piece of the puzzle. It's a concept so strange that even Einstein called it spooky action at a distance. I'm talking about entanglement. So to finally crack this puzzle, we need to get one key distinction. If I say a pet and a fish, I'm talking about two separate independent things. In quantum speak, that's a product state. But pet fish, that's different. It's a brand new fused concept. This is what's called an entangled state, where the two original ideas are so deeply linked that they completely lose their independence and become one thing. And that is the magic of entanglement. Once pet and fish are entangled into the single idea of pet fish, you can't touch one without instantly changing the other. They're forever linked. So the context, lives in a bowl, collapses the fish part of the concept, right? But because they're linked, it simultaneously collapses the pet part into a state that's compatible, something small, aquatic, kept in a home. Suddenly, the guppy emerges as a perfect fit for this brand new entangled reality. Now, I know this might sound like some wild philosophical analogy, but here's the kicker. When researchers actually built a mathematical model based on this quantum framework, its predictions were shockingly accurate. For example, the model predicted that the typicality of goldfish as a pet fish would be 0.48, and the actual data from human experiments also 0.48. This bizarre theory, it actually works. But the power of this idea doesn't just stop with simple phrases like pet fish. No, the theory suggests that entanglement might be the fundamental glue that holds all of our thoughts together, allowing us to build entire sentences. Think about a simple sentence. The cat eats the food. Our minds don't process that as three separate, disconnected items. Cat, eats, food. Instead, we instantly weave them into a single, coherent, entangled system where every word shapes the meaning of all the others.
So here's how that works. All the concepts in the sentence are linked. If I tell you the cat is a specific cat named Felix, that one new piece of information instantly ripples outwards. Eats collapses from just a general action to the more specific what Felix eats, and food collapses from all possible foods to the specific food being eaten by Felix. They all snap together to tell one single interconnected story.
And so, we end up right back where we started, with that really provocative question. Is your mind literally a quantum computer? Maybe, maybe not. But what this theory suggests is that the mathematical tools of quantum mechanics, superposition, collapse, and entanglement, give us a startlingly powerful way to model the flexible, context-dependent, and deeply interconnected way that we think. It seems the spooky action happening inside our heads might be just as strange as the spooky action happening out there in the universe.